All right, today we're going to crack open the universal rulebook. You know, the one that governs absolutely everything, from an exploding star down to a simple breath. We're talking about the rules of energy.
So, let's kick things off with a little puzzle for you. What on earth could a massive, chaotic lightning bolt and a totally calm, sleeping cat possibly have in common? I mean, they seem like complete opposites, right?
Well, the answer is they're both playing the exact same game. They have to follow the fundamental rules of energy. The best way to think about it is like the universe is this giant board game. It's got its pieces, its moves, and one single golden rule that can never, ever be broken.
Okay, so here's our game plan. First up, we'll get to know the pieces on the board, energy's many forms. Then, we'll learn the official moves, which is how energy moves. After that, we'll get to the most important part, the one unbreakable rule. And to wrap it all up, we'll be watching the game unfold to see it all in action. So, let's jump right in with Section 1, the pieces on the board. I mean, you can't play a game if you don't know what you're working with, right? In physics, energy is held in different stores, which are kind of like containers, just waiting to be used.
And here are the main players. These 7 stores hold literally all the energy in the universe, from the sun's nuclear power to the heat in your morning coffee. But don't worry, we're just going to focus on a few that you run into every single day.
First up, kinetic energy. This one's super easy. If something is moving, it has kinetic energy. That's it. A car speeding down the highway has a ton of it. A baseball flying through the air has it. It's the energy of motion.
Next is gravitational potential energy. The key word here is potential. It's energy that's stored up, just waiting. Picture a roller coaster car, paused at the very, very top of a hill. It is absolutely loaded with potential energy, just waiting for gravity to take over. Then there's chemical energy. This is the stuff that's locked away in the bonds between atoms. Think about the gasoline in your car, the charge in your phone's battery, or even the sandwich you had for lunch. All of that is stored chemical energy, just waiting for a reaction to let it out.
And we can't forget elastic potential energy. You definitely know this one. Ever stretched a rubber band? That tension you feel? That's stored energy. It's completely spring-loaded, just waiting for you to let go so it can snap back. Okay, so now we know our game pieces. But a game's no fun if the pieces just sit there. So how do they move across the board? How does energy actually get from one place to another?
Well, it pretty much moves in 4 main ways. It can be transferred mechanically, like with a push or a pull. It can be transferred electrically through a current. There's heating, which is pretty self-explanatory. And there are waves, like the sound and light waves bringing this to you right now.
Let's look at a simple fan to see this in action. First, energy is transferred by an electrical current through the cord. That electrical energy then does mechanical work by making the fan's blade spin. And at the same time, you hear that whirring noise, right? That's energy being transferred away as sound waves. It's a whole chain reaction. All right, now we get to the really fascinating part, the big one. No matter how energy is being stored or how it's being transferred, from lighting a tiny match to a star-going supernova, the entire universe is following one single, non-negotiable rule. And I'm not exaggerating here. This isn't just some guideline. It's a fundamental law of physics. It's the master rule of the entire game. And what's wild is just how simple it is. And there it is, the principle of conservation of energy. All it means is that you can't make energy from nothing, and you can't make it vanish into thin air. All the energy that has ever existed in the universe is still here, right now. It's just changed its form or its location.
So, let's put this all together. We know the pieces, the stores. We know the moves, the transfers. And now we know the golden rule. So let's watch a quick game unfold with something we've all seen 1,000 times, a bouncing ball. So when you're holding the ball up high, it's packed with gravitational potential energy. The second you let go, gravity starts converting that potential energy into kinetic energy, the energy of motion. And right before it hits the floor, it's at max speed, all kinetic, no potential. But wait a minute. Why doesn't it bounce all the way back up to your hand? Did we just lose some energy? Did we break the rule? Nope. This is what's so cool. The energy didn't disappear. When it hit the ground, some of it was transferred into heating the ball and the floor. Just a tiny bit. And some of it was transferred as the sound you hear. So the energy that could have been used for height just went somewhere else. And if you look at the numbers, the total is exactly the same. And that right there is the crucial point. The cosmic energy bank account always balances. 100% of the energy you start with is there at the end, always.
It might be in a less useful form, like heat that just spreads out, but it is never, ever gone.
So that's the whole game in a nutshell. We've got energy stores, those are the pieces. We've got energy transfers, those are the moves. And we've got one golden rule that governs every single play. The total amount of energy is always conserved. Which leaves us with a final, pretty mind-bending question to think about. If energy is never destroyed, just constantly changing and spreading out, where is all that energy from the Big Bang ultimately headed? What does the universe actually look like at the very end of the game? Thanks for watching.